Hi, everyone. I'm Patricia Nadeau. So as of today, we still have fountaining at Fissure 8. The fountains are reaching about 200 feet high. The cone itself is now about 160 feet high, so the appearance of the fountains is possibly a little bit lower than previously. We still also have an ocean entry from the lava flow in the channel down at Kapoho. There's a lathe plume that today has been blowing a little bit onshore because of easterly winds, but it didn't reach very far inland. There's also areas of hot water upwelling offshore. At the summit, we had another of our small explosions, 3:19 this morning local time. The equivalent earthquake magnitude was preliminarily calculated to be a 5.3, but again, that's just equivalent earthquake size. It's actually a volcanic explosion. We also have a little bit of oozing lava at Fissure 16 and 18. And my specialty is actually volcanic gases. So an update on that. Yesterday we measured 1,800 tons per day of sulfur dioxide at the summit and 19,000 tons per day of sulfur dioxide in the lower East Rift Zone. Lower East Rift Zone, that's a slight increase over last week. And in terms of other projects that we're doing with the gas group, we have drones that are flying to take SO2 emission rates for us and also get gas chemistry from within the plume. And we're also doing two different kinds of gas chemistry measurements, mostly down in the lower East Rift Zone, to try and evaluate how changes in gas chemistry may relate to changes in the eruption.
Hi, so I'm part of a cooperative project between the USGS and University of Hawaii Hilo doing geochemical monitoring of the lava as it's erupted. So lava samples are collected in the field and brought to our lab where we analyze them for certain elements that give us an estimate of the temperature of the lava as well as how long that magma may have been stored or what changes may have happened to it underground. When the eruption first started, we were able to report within a few hours that this was old stored magma, lower temperature, viscous, very high in the elements that accumulate over time when magma gets stored and crystallizes. Some of these early lavas were some of the most chemically evolved and coolest lavas we've ever seen on Kilauea. Temperatures as low as about 1050 centigrade, so about 1900 Fahrenheit. So less than about 10 days after the eruption began, the lava composition suddenly shifted, showing a decrease in the amount of that stored magma. We started seeing more and more of this newer, hotter lava, possibly from the Pu'u'o source, in the intruding dike. We alerted the team, field teams, that this hotter lava would be less viscous and could potentially move faster and travel farther from the vent. Soon afterwards, eruptions from vent 20 produced those big flows that reached the ocean in about 2 days. And then over the next 10 days, so by about May 21st, the lava chemistry really leveled out at compositions that are mostly this newer, hotter lava, with only a small portion of stored lava still in them. And that's still going on right now. We estimate the temperatures to be in the range of about 1135 to 1145 C, so that's about 2075 to 2090 degrees Fahrenheit. That's very similar to what we were seeing at Pu'u'o, a little bit cooler. And the arrival of this hotter lava was followed by this high volume, sustained this outpouring of lava from Fissure 8 that's still going on. The new lava also includes visible olivine crystals, though they are very small, some of which are beginning to look like the type of olivine we were seeing in the Summit Lava Lake before it drained away. So at this point, we may be starting to see Summit magma arriving in the system, so that's something we'll be checking for. The lava compositions overall aren't exactly the same as Pu'u'o or Summit lava, but we really don't expect them to be. They're traveling, 45 kilometers through the rift zone, that's 28 miles, where they're going to cool, they're going to mix with all the stuff that's stored in the rift zone and end up looking a little bit different at the end. So that's where we are right now.
Wow, that was great info. That's a tough act to follow, Cheryl. So good morning, everybody. My updates are very brief and pretty much status quo. Today's day 35 of the park closure. According to this morning's operations briefing, the magnitude 5.3 explosion / earthquake reported no additional damage to Chain of Craters Road, and that's really what we're keeping a close eye on because, of course, if we have to use Chain of Craters Call Upon a Road as an evacuation route, we need to make sure the rest of Chain of Craters is passable, and it is. Speaking of roads, next week, Hawaii Department of Transportation will begin repairs to Highway 11 on the Hilo side of the park entrance. You might recall that we had significant surface cracks on Highway 11 following the 3.5 earthquake back on May 16th. So it's been pretty bumpy up there for drivers and continuing to degrade with every earthquake that makes a difference. There will not be a closure to Highway 11, but flaggers will be directing traffic. So motorists are advised to drive with caution, obey all posted signs. And no confirmed start date yet, but it is planned for next week. And that's all I have.
Aloha, everyone. Well, we have seen a weakening of the trade wind speeds over the last couple of days. The trades have not completely disappeared. We're still seeing some semblance of easterlies near the Big Island, but it looks like the speeds are quite a bit lower. There was also a little bit more of an east-southeast component to the winds, and what that means is that some of the emissions from the lower East Rift Zone can spread up northwest toward Pahoa and toward Hilo, although some of our guidance now is showing that the trade wind direction is going to settle back in from the east-northeast, albeit at light speeds for the next couple of days and on into next week, actually. So we're expecting that most of the emissions from the volcano will travel down toward the southwest, toward Pahala, but we could see, especially at night when the land breezes take over, there could be some piling up and poor ventilation with a lot more emission staying there locally where everything is going on. One of the things that we saw this morning with a band of showers coming in was quite a bit of enhancement from the heat from the lower East Rift Zone is actually adding to the instability locally over a small area. We saw that yesterday. We saw it again this morning as a band of showers comes through. So we do expect that as trade wind showers move in off the water, that there will be some locally heavy showers there, right there near the lower East Rift Zone as those bands move over. And that'll probably continue for several more days. I think that's all I have.
Our first question comes from Elima Loomis. Your line is open. Please state your affiliation.
Thank you very much. This is Elima Loomis with EOS. My question is for Patricia. How do the volumes of volcanic gases that you mentioned compare to those seen at previous eruptions at Kilauea? And what information can we learn about the eruption by studying the chemical makeup of these gases?
So I will preface this by saying that I started this position 2.5 weeks ago, so I'm still getting up to speed on the historical data. For right now, I can say that at least in terms of the more recent lava lake Halemaumau phase of the eruption, summit emissions are less than half of what they were. Pu'uo'o in the previous stages of this eruption back in the early 2000s was emitting many tons per day of sulfur dioxide, and it's down to about just a few percent of total SO2 emissions right now. And lower East Rift Zone is emitting more sulfur dioxide than we've seen in a while from any of the eruptions. So we can use the volumes of the gas as a bit of a proxy for how active the volcano is and how much lava is being emitted, although it's not a direct one-to-one relationship. And then in terms of the chemistry, magma tends to degas carbon dioxide at deeper levels, so earlier in its ascent from deep within the Earth. So because the magma is now deeper at the summit, we see more carbon dioxide emissions at the summit than we do down in the lower East Rift Zone, where the magma is more shallow and coming out as lava. So that's why we see the enhanced SO2 emissions down in the Rift Zone, because that's where the activity is focused right now. So ratios of different gases and different chemistries can help give us clues about what the magma is actually doing underground. And we don't know everything about it, but we're working on it, trying to figure out what's going on down there using the gas chemistry.
Does that conclude your question, Alima?
Yes, thank you.
Thank you. Our next question comes from Sherry Bracken. Your line is open. Please state your affiliation.
Hi there, I'm with Mahalo Broadcasting and Hawaii Public Radio. Cheryl, you talked about the fact that you guys are testing the lava. There was a lot of publicity early on about the lava being sent back to a university that I believe was in New York to do testing. What are they doing? What are you doing? What's the relationship? Are they out of it now that you guys are in? Just give us a sense as to the relationship and roles, please.
Oh, sure. So this is it is a cooperative project, and we at UH Hilo have capability of doing certain types of analyses, but definitely not some of the more detailed chemistry. And so we had a partner we work with at Hamilton University was offered to basically shoot our samples up to the beginning of the line and run some for us so we could get more detailed chemistry, things like silica percentage, which we can't really do very well here. So we could confirm that some of these lavas that we saw at the beginning were of the most evolved samples we'd actually ever seen before on Kilauea. And then we also work with other USGS partners that do other types of analyses. So in order to look at magma in more detail, we look at the whole rock. But you can actually break it down into looking at glass and crystals, and for that you need a machine that can use a very finely focused beam to look at the glass composition versus the crystals and the different minerals there, and that we use at the USGS Denver labs there. They use an electron microprobe. And another lab there, which is laser ablation ICP-MS, so it's a mass spectroscopy. They can do trace elements, so elements that are present in very small portions, and they can do in tiny spots. And so they offered basically to jump in and help us do these analyses really quickly too. So it's been a great cooperative project, and it will continue to expand as others sort of join in and help us fill in the story of the magma and the story it's trying to tell us.
Thank you very much.
Thank you. Our next question comes from Michael. Your line is open. Please state your affiliation.
I'm with the Hawaii Tribune Herald. I got a question for Cheryl. You mentioned olivine crystals in the lava, and there have been some social media reports that got picked up by internet blogs and the like about olivine gemstones raining from the sky, which sounds a little bit questionable. I was wondering if that's even remotely possible or plausible, if there have been reports of that sort of thing, and also how do you spell your first name? I think Cheryl can be spelled multiple ways.
Yes, of course. So I'll get the easy one first. Cheryl is Cheryl. And the second one, there is not olivine raining from the sky except in clumps of lava. So if you happen to be where tephra is falling from the sky, there is tiny olivines embedded in it, but you probably aren't going to see them. We did see this report or this Twitter post. The pictures they showed of these olivine are definitely not what we're seeing in the lava. Those are from older picrite lava. So these lavas that are, there's a few eruptions that have happened in the past that have just tons of olivine in them, and those are like the 1840 flow, or think of Green Sand Beach off of Mauna Loa. Those flows have huge amounts of pretty big olivine. What we're seeing are tiny, and they do not separate from the lava themselves. So you have to crush the lava to get them out and find them. And so I think this is pretty much a non-story. Unfortunately, it would be fun.
Yeah. All right. Well, thank you.